Okay, so this second part here, we're solving second degree equations using graphical approaches. We can do these graphically, or we can do them using other techniques, right? We can go graphically, or we can go algebraically. If we graph this thing, what we need to start with is anytime we have a quadratic, we pull everything to one side. So this is going to be 2 sine squared x plus sine x minus 1 equals 0. And then we just have to graph this thing and look for when it equals 0. Now on my calculator, I've got that graphed out already, and you can see that 0 seemingly at, looks like pi quarters and 1, 2, 3, 4, 5 pi sixths. So it looks like pi quarters and 5 pi sixths are going to be my solutions just looking at the screen, and those are the only solutions between 0 to 2 pi if we look at that there. Okay, so my general solution would be pi quarters plus 2 pi n and 5 pi sixths plus 2 pi n. N is an element of the integers. Let's see if I did that correctly reading the points off my graph. I may not have. So all I do for this to algebraically solve it is I get the same general equation, and now I factor it. So my lead bracket's going to be a 2 sine x, and it's going to be 2 sine x minus 1 times sine x plus 1. And then my solutions here are going to be sine x equals 1/2, positive 1/2, or sine x equals -1. At this point, I'm not doing anything else different with it. I just solve these as though they were standard questions. So this should be pi sixth and 5 pi sixths. So apparently I missed one on my graph. And then sine x equals -1 at 3 pi halves. So let's see if those match up to my things here. And they don't seem to. That's funny. Anyhow, let's do this. Window settings, and let's change our x scale to pi divided by 6. Anyhow, these are the correct answers. Why I don't have those graphically, I haven't yet decided. I'll figure that out later. To solve these ones, again, basically the same technique. We factor it. 2 sine a minus 1, 2 sine a plus 1, and then it's equals 0. And then I just have to factor these out to both of these. So this is going to be sine a equals 1/2 or -1/2, which is going to happen at pi sixths, 5 pi sixths, 7 pi sixths, and 11 pi sixths. All of the pi sixths family of graphs. This one up here, I take out tan. So I get tan x times tan x minus 1, plus 1, equals 0. So tan x equals 0, or tan x equals -1. This is going to happen when x equals 0 or pi. And this one, tan x equals -1, if I just do my quick unit circle here, is going to happen at wherever that point is there, 3 pi quarters and 7 pi quarters. Whew. And that should be it. Okay.
One question to stay for
So this thing here, again, I basically take the same idea. 0 equals a squared minus 3a minus 28, which is going to be a minus 7 and a plus 4. Wait a second there. Yeah, that's right. And then so, but my a isn't really a. My a is really cosecant. So I can say a equals 7 or a equals negative 4, and I can then change that to cosecant x equals 7 and cosecant x, close enough, equals negative 4, and therefore I can now say sine of x equals 1/7 and sine of x equals negative 1/4. And those are the things that I can get in my calculator. So at this point, we're pretty much done. I'll just demonstrate one of these. So I'd go over to here. I would make my calculator turn on. And then I can go sine negative 1 of 1 divided by 7. Quick, make sure I'm in degrees. It wants degrees. So 8.21 degrees would be their answer. Or 171.79 degrees, which is 180 minus that 8.21 degrees. So you need to include both. In this one here, I'm going to do basically the same thing. 2a squared plus 5a minus 3 equals 0. And then this is going to be 2a, got to go to plus 6. So a equals 1/2 or negative 3. But what that really means is that cosine of x equals 1/2 or cos of x equals negative 3. Now, this thing is going to happen at, what is that going to be? Pi thirds and negative pi thirds. I would also say 5 pi thirds, but they want it over this domain. So it'll be those two values. This thing never happens. Sine x is never equal to anything greater than 1 or less than negative 1. It has to be a fractional value. So cos x is never equal to negative 3. So my only two solutions are those two. Check, check.